Welcome to this video on the terms Artificial Intelligence, Machine Learning and their relation, presented by Professor Manish. Machine learning, or ML, is a subfield of artificial intelligence that enables computers to learn patterns from data and make decisions without explicit programming. Unlike traditional programming that relies on rules and data to generate output, ML systems use data and output to learn the rules, essentially creating a model. Artificial intelligence, or AI, is a broad field of computer science focused on building systems that can simulate intelligence. In simple terms, AI allows machines to think, reason, learn, and make decisions like humans. Examples include problem-solving systems, language understanding, vision, and decision-making applications like self-driving cars. The core idea behind the relationship between AI and ML is that AI is the goal, and ML is one way to achieve it. AI aims to make machines intelligent, while ML allows machines to learn from data to become intelligent. ML is a subfield of AI for two main reasons. First, AI includes many other approaches besides ML, such as rule-based systems, logic, and search algorithms. ML is just one approach among many. Second, ML focuses on data-driven learning, using data to automatically learn rules, in contrast to traditional AI, which relies on handcrafted rules. Consider the example of email spam detection. An AI rule-based approach might flag an email containing free money as spam. An ML approach, however, learns from thousands of emails to automatically detect various spam patterns. Both are AI, but ML offers a more powerful and scalable solution. Here's a quick comparison. AI is a broad field with the goal of intelligent behavior, using rules, logic, and learning. ML is a subfield of AI, aiming to learn from data through a data-driven approach. As a final insight, AI represents the complete system, such as a diagnosis pipeline. ML serves as the core engine within that system, utilizing models like CNN, LSTM, or QSVM to drive the intelligence. The Turing test, proposed by Alan Turing in 1950, determines whether a machine can exhibit human-like intelligence. It involves a human interrogator communicating with a computer and a human responder, both hidden, to see if the interrogator can distinguish the machine from the human. The Turing test involves three participants: a human judge, a human participant, and a machine AI system. The judge communicates with both, usually via text. The goal is for the judge to be unable to reliably distinguish between the human and the machine. If the judge cannot tell the difference, the machine is said to have passed the Turing test. In summary, AI is a complete system that aims to replace or simulate intelligence. Machine learning, on the other hand, can be considered a vital component or engine within that larger AI system. The Turing test is important in AI because it addresses the fundamental question: can machines think or behave like humans? Instead of defining intelligence directly, it tests behavior. Key features include focusing on natural conversation, evaluating human-like responses, and being based purely on output behavior, without needing to understand the internal workings of the machine. However, the Turing test has limitations. Imitation is not equal to true intelligence. A machine may mimic responses without genuine understanding. It is a narrow evaluation, only testing conversation, and not other aspects like vision or reasoning. Finally, the AI can intentionally give vague or misleading answers, essentially tricking the judge. Machine learning can be viewed as an extension of statistics. The goal is to learn patterns and predictions from data using probabilistic and mathematical models. The core idea is that ML combines data, a statistical model, and optimization techniques. ML relies on probability theory, statistical inference, and optimization to learn from data, instead of using hard-coded rules. In the statistical view of machine learning, data is treated as a random sample from an unknown distribution, which ML tries to estimate. The model is represented as a function, where y is the output, x the input features, and theta represents the parameters to learn. Learning then becomes the process of estimating the best theta parameters. Let's explore the connection between ML and statistical concepts. Training data in ML is equivalent to sample data in statistics. A model is a statistical model, and parameters correspond to coefficients. Training is estimation, prediction is inference, and the loss function relates to likelihood or error. Machine learning is often called statistical learning because it learns from data distributions, uses probability models, applies inference and estimation, and optimizes expected error. This fundamental reliance on statistical principles makes the two fields highly interconnected. The final insight is that machine learning is a statistical approach where models are trained using data to estimate underlying patterns and make predictions by minimizing error or maximizing likelihood. Thank you for watching this video. We hope this has provided valuable insight into the relationship between artificial intelligence and machine learning.